What is the meaning of link aggregation? So for example, if I select two switch, okay, let us say I select two switch. Let's say I draw it here first and then I do the discussion. So say I've got here switch number 1 that connects to your switch number 2 over 2 links. Now the problem is, that if you have dual link between the two switch, we're trying to make the topology as redundancy in mind. But the problem is if an STP will actually come in the picture and it will block one of the link. This is your switch 1. This is your switch 2. If this is the picture, then of course an STP will come in the picture. It will say, okay, one link is blocked. If you have 5 links, 6 links between the two switch, only one link will be active. Remaining all the links will be in block state, right? That is the reason why you need is, you need something called as the concept of link aggregation. Link aggregation, where you can bundle the interfaces into one logical link. And STP thinks it's one link between the device. So if I bundle this two link into one logical link, so there is a process called as link aggregation by which I can logically bundle these two links together. Okay, and I will ensure that STP to think like it is connected with one logical link between switch 1 and switch 2. Rather than with two individual link, it is connected over one single logical link. STP will think that. Okay. Now with help of link aggregation, what is the better thing you get? What is the major thing you get? You get better bandwidth. So for example, if these links are 1 Gbps, this is also 1 Gbps, right? With link aggregation, what you do is you get better bandwidth. So the aggregated link will have bandwidth of 2 Gbps right now. Okay. So the first advantage that you get is called as aggregated bandwidth okay. And the second thing that we get is load balancing of your traffic. Now what is the meaning of it? Let's understand. So let us say behind this switch number 1, I might have some clients. Behind switch number 2, I might have some servers. Imagine that I've got some clients over here, some PCs, and behind this switch number 2, I've got some servers. Right now, what will happen if the clients wants to communicate over the servers? So I've got some 100 clients here, 100 servers here. So few client traffic can go over the first link, and the return traffic can come over the second link. Okay. Now few client traffic, their traffic can actually go over the second link, and the return traffic can come over this link, right? So the idea is, you understand, right? So I have load balancing over here. So I'm not depending only on STP if it is, active standby concept. So only one cable is taking my traffic all the way from the client to the server. If I've got, link aggregation over here, this is the member interface. This is called as a member interface. So all my member interfaces are part of my load balancing process. Right? So some traffic will go via the first member interface, some traffic will go via the second member interface, and return traffic will also fall between that member interfaces. So I'll have better load distribution, better usage of the links. What I mean, right? And if you want more bandwidth, see, clients and server communication, needs more bandwidth. So rather upgrading, your switches with a better bandwidth based switch, what you can do is you can do this concept called as link aggregation, right? And upgrade the bandwidth logically. Okay. Now to do link aggregation, guys, is a very famous thing. So we can do between the switch, or you can do between the switch and a server also. So if I have got a server, right? Let us see, to the server also I can have a dual, link over here, right? And I can do link aggregation here also. Okay. We have different types. So tomorrow, next advanced topic when you study, you have, link aggregation that is called as multi-chassis link aggregation. In data center world, the link aggregation terms, changes. But this is called as, point-to-point link aggregation. You should understand this first. Okay, so what is the basic advantage? You get aggregated bandwidth, you get load balancing of your traffic, and we're bundling the member interfaces, and STP will assume that they're plugged via a single link. All right. So link aggregation runs with, two modes. So in case of Cisco switches, or also with multiple vendors, there are methods by which I can say lag method, integration method. Now this term is used actually interchangeably by multiple vendors. So some vendors tell the term of lag with a term called as trunk. Some vendor calls this as with EtherChannel. So Cisco tells it specifically with EtherChannel, right? Some tells with as a port grouping, right? Some tells this as a NIC teaming. So there are multiple terms that has been offered to this concept called as link aggregation. Okay, Cisco calls this as EtherChannel, right? Now, what I want to do is, I want to configure link aggregation. That means I have got multiple ways, right? I've got ways to configure lag or EtherChannel. First is called as manual method. Okay, first is called as the manual method. Second is called as the dynamic method. Dynamic method, we use, couple of protocols. One is called as PAGP, that is called as Port Aggregation Control Protocol, which is basically, Cisco proprietary. It is only used between the Cisco switches. And another protocol is called as LACP, which is open standard. So generally it is recommended to go with, LACP, not with manual, not with PAGP. Okay, because if I have a Cisco switch, say switch 1 is Cisco switch, if switch 2 is a non-Cisco switch, then I cannot go with PAGP here to form my link aggregation dynamically, right? I have to go with LACP only, because LACP is open standard. Any vendors will run LACP. Even Cisco is not running PAGP nowadays with its Nexus switches. Even they don't run PAGP. With Catalyst switches only, PAGP is there, but with other switches also it is not there, because it's of no use. Like, okay. So we have multiple method, manual method, and we have method of PAGP LACP in Cisco to form link aggregation, right? Let's do this lab and let's understand it. Any question here? Understood what is the meaning of it?
Yeah.
Okay, one more thing before the lab. I told you that we will have load balancing of the traffic, right? So the clients can talk to the servers, and the traffic could be load balanced between the multiple links. This load balancing to happen, we use something called as load balancing algorithms. Right? So the switches, wherever you have enabled LACP based link aggregation or PAGP based link aggregation, these protocols have got load balancing algorithms. These algorithms are based on, source IP, destination IP, source MAC, destination MAC, right? Or combo of IP or combo of MAC, right? That means when the traffic is going from the client to the server, say the load balancing algorithm on switch 1, it is configured as destination IP, right? So the client will say, okay, if I reach a destination IP called as X, for X, the switch will decide that use, member interface number 1. If the destination IP for some clients is Y, it might go to a different member, right? So based on the destination IP or based on the different MAC addresses that you're trying to reach, your load balancing algorithm will decide and will figure it out that which interface could be the port to forward the traffic towards this, in the link aggregation group. Okay, remember that. So let's do the lab. Let's actually bring up 2 switches. So I just bring this things into part. And let's say I have got here or what I can do is, okay, no problem. I select 2 switch over here. Okay. So say I selected, switch number 6 and switch number 7. Okay. I might have some users behind switch 6, some users behind switch 7, think in that way. But the most important thing is I have got, say, 2 links. C00 both side and E01 both side. Now, the thing is, you can have 8 interface in the bundle. You might ask me that, okay, how many interface can I have in the bundle? I have got 8 interface that I can go in the bundle, right? Up to 8. In case of, manual or in case of PHP. Okay, so basically, this is the concept. Manual and PHP lag supports up to 8 member interface. And LSCP supports up to 16. But out of which 8 members will be active and 8 members will be standby. So for example, you connect 16 cables between the 2 switch, okay, all out of 1 GB, 1 GB each. Now before that, understand that member interface, if they are of different speed, then lag is not possible. So let us say out of 8 interface, you told 5 interfaces of 10 gig, 3 interfaces of 1 gig, you cannot form lag with all the 8. So make sure that the bandwidth should be all equal. Okay. So in case of LSCP, what happens is you can connect 16 links between the 2 switch, but out of which 8 will be active and 8 will be standby. From the active members, if anyone fails, from the standby, 1 member will become active. Okay. So remember that. So with LSCP, it is going to be up to 16 max. So that is the concept. Okay. Does it switch get started? So I've told you that we have got 2 methods to configure, LSCP, right? So the 2 methods are, one is manual, one is dynamic. For configuring link aggregation, we have got 2 methods, as I've told you. Okay, so basically, think about, link aggregation. If I say there are 2 methods, so first method is basically your manual. First method is your manual, where you can manually go to both the switch and bring these interfaces in a link aggregation group. Okay, so this will be the member interface, and say we normally call that as a port channel. So I give a port channel ID, say it is 12, and similarly this interface is bundled in a logical port channel, say it is 21. This port channel number is locally significant. It can be same, it can be different between the 2 switch. So basically here on PO12, I've got 2 member interface. On PO21, I've got 2 member interface. And make sure that the cable speed or the link speed of both the members should be equal. Okay. So manually you have to go and set the link aggregation both sides. That is one job. Second job is, it is not recommended because, we can have man-made errors, and other advanced thing is also considered because manual is not, preferred. Because you might go to E01, E00 and configure manually link aggregation. Okay, tomorrow what you can do is you can unplug, E00 other side and, want to connect in different interface in that lag group. In this way, things will be a little difficult to manage, right? So that is the reason manual is not preferred. You go with what? Dynamic. In dynamic, you have got 2 protocols to work with. One is PHP and one is LSCP, right? PHP is a Cisco proprietary, as I've told you. So only between Cisco switches we can use it. LSCP is open standard. So between Cisco and non-Cisco devices, we can use LSCP. Recommendation is this. Okay. Now, when you talk about PHP stands for Port Aggregation Protocol. Okay. It has got 2 modes. It has got 2 modes. The 2 modes are dynamic. Basically, the 2 modes are named as desirable, okay, and auto. In case of PHP, the modes are called desirable and auto. In case of LSCP, we've got 2 modes. The modes are called as active and passive. Very, very important to remember this. Okay. So if I configure PHP based link aggregation, that means I'm saying that, hey, one side I can configure as desirable, one side I can configure as auto. So what will happen is the port channel having the member interface, if you configure that port channel with a desirable option, that means this switch number 1 will go and send something called as PAGP negotiation packets. PAGP negotiation packets, right? Where it can go and ask that, hey, I want to become, link aggregation with you. These are my properties of link. For example, my bandwidth is 1 GB, 1 GB. I'm a trunk port. My VLANs allowed on this particular ports are so and so. So you tell all the properties over the negotiation packet. If everything is matching on the remote side, it will give you a keep alive packet, which says, yes, I want to go and form link aggregation with you. So auto is basically the side that is configured in the auto mode will be like, listening for your negotiation packets. The side that is configured in desirable mode will be actively sending the negotiation packets. Okay, so it is recommended that one side if it is desirable, one side if it is desirable. Okay, and if the parameter matches, we can form link aggregation between the two switch. If one side it is desirable, one side it is auto, we can form link aggregation between the two switch. But if both side is configured as auto, lag is not possible. Okay, because nobody will start the negotiation process, nobody will send any traffic, everybody will be in the auto mode, means what? They'll be in listening state, right? So auto is not possible. Similarly, if it is LSCP, you configure one side as active. You go to the port channel and you say, hey, port channel, this is the active based port channel, means you are running LSCP in active mode. And you can say this port channel that, hey, you're running LSCP in passive mode. What will happen is active will send negotiation packets, passive will wait to listen for the incoming negotiation packets, and if the parameter matches, then it will give a keep alive and the lag will be formed. Right? So the whole idea is, if I go with LSCP, both side active, if you configure, lag is possible. One side active, one side passive, lag is possible. But both side passive, lag is not possible. Because passive means nobody will start the negotiation of any LSCP packets. Am I clear with this?
Yes.
Okay, very important. And also somebody might ask me that, okay, what if one side is PAGP, one side is LSCP? Never ever possible, because the protocols are different, right?
I was just to ask.
Yeah, not possible, right? Because the language of protocols are different, no? So they'll not be able to understand each other's language. Okay, so let's consider this. Let's show you all the three options. So I go to my switch number 6 over here and switch number 7 over here, and I'm configuring this as a link aggregation. So drawing wise, you can draw like that. Circle dash like that. You can have a drawing like that. Okay, and you can say that this is running PO12. Okay, this is my PO12 having this member interfaces here, and say for sake reason I consider this as PO number 21. I can have same number, not a problem, but just for fun. Now why 12 might be switch 1 goes to switch 2 and switch 2 goes to switch number 1, like that. So what I can do now is I can go to this particular switch, which is already open, I believe. Yeah. Switch number, which is 6 over here. Let me close all of them because they're all powered off. So switch number, if I say enable global config mode, host name, so this is switch 6, whatever, something like that. And likewise this switch, enable config space T, host name switch 7. First of all, what I want is the member interface should be powered up. Okay, so we have got order of operation here. Order of operation means step by step we should follow the process to configure EtherChannel. Otherwise, EtherChannel cannot be formed properly. Okay, step by step approach we should take. First approach is go to the member interface and shut them off. Interface E0/1, or I can say interface range E0/0, E0/1. I can say shut. Similarly, I can go to switch number 7. I can say interface range E0/0, E0/1 shut. So shut the ports off first of all. Okay. Next, your job is to do what? Say, go to both the ports, which is actually shut down. Go to both the ports again and say port channel, or the command is channel group. Okay, command is channel group. To creating the port channel, the command is channel group. Then the group ID is 12. Mode. When you say mode, give a question mark, you'll find multiple modes over here. On means manually you are configuring it, no protocols. When I say mode on, it means it is manually configured. Okay, if I say desirable or if I say auto, that means I'm going with PAGP. If I say active or if I say passive, that means I'm going with LACP. Okay, so I'll go with on. So manually I'm saying that, hey, these two interfaces are part of your, port channel number 12, and this is mode as on. Then I hit enter. Okay, so manually we have made it. So similarly on that side also, you should go and manually make it. So go to the interface range E0/0, E0/1, channel group, mode on. Sorry, channel group number is 21, then mode on, right? And next you should do what? Say no shut. Because I'm already inside both the member ports, I can say activate the port with no shut and activate the port with no shut. Okay, and then you can go to the port channel itself. You can say interface port channel, port channel number 12, and you can say switch port trunk encapsulation.1q, switch port mode trunk. So rather configuring the member interfaces as trunk, you can go to the port channel itself and configure the port as trunk. Okay, because the member interface are now part of the port channel. So you can come back over here, or basically you can go back to the interface and say no shut. Then you can come back. You can go and say interface port channel number 21. You can say switch port trunk encapsulation.1q, switch port mode as trunk. And okay, that's it. So basically you can go to the port channel and configure them as a trunk port. Now to verify this, you have to come to switch 6 and say show EtherChannel, summary. This is the command. Show EtherChannel summary. When you hit enter, you can see that they've got a port. You can see this output in a bigger way. I gave the command to show EtherChannel summary. You can check that, the port ID is 12. Okay, so this is the port channel number, and I've got here certain status over here, S and D. So S stands for, capital S is a layer 2 port channel, and D stands for, capital D stands for it is down currently, because I gave no shut, it will take some time because STP is also running, on the logical link. That is the reason. This is the member interface. Okay, so let's go and again we verify this. If I go to switch number 7, is dynamic Q21 is trunk. It says some error over here. E00 is not compatible with PO21. Okay. If that is the error, it is saying that the logical, sometimes you get this kind of error on the older switches. So interface range, it's E00, E01 all the way, E00, E01, you can say shut, and then I can say same command here, interface range E00, E01, can say shut. Okay, and then I can say this switch port trunk encapsulation.1q, switch port mode as trunk. So rather giving the trunks on the port channel, I'm giving the member interface only. So go to both the ports and say switch port trunk encapsulation.1q, switch port mode, and say no shut to member ports, no shut to the member ports, activate the ports. Okay, and you can see the port channel is up right now. Switch number 7 also is port channel number 21 is up right now. And if I go and configure and verify this, show EtherChannel summary, I can see this is the good output, SNU. So S stands for it is layer 2, and U means capital U means in use. Okay. And these are the member interfaces. That is part of the bundle. And capital P means bundled in the port channel. Right, all good. Likewise, switch 7. So EtherChannel summary. I can see this is port 21. It is capital S, capital U, and capital P, all good output I can see over here. So these ports are part of my port channel right now. Okay. I hope it is clear.